Namaste, and a very warm welcome to our channel, Future Java Champions. Today, we are diving into a super important topic that can make your Java applications lightning fast: database indexing strategies. Have you ever wondered why some database queries take ages, while others are almost instant? Well, the secret often lies in indexing. Think of a database index like the index at the back of a textbook. Instead of reading the entire book page by page to find a specific topic, you just look up the topic in the index, and it tells you exactly which page to go to. This saves a lot of time, right? In this tutorial, we will explore what database indexes are, why they are crucial for performance, and how they work with your Java applications. We will cover the most common types, see practical examples, and learn some best practices. So, grab your virtual notebooks, and let us begin this exciting journey. Alright, let us start with the most common and powerful index type, the B-tree index. This is the default index type for most databases and is incredibly versatile. Imagine you have a large phone directory. If you want to find someone by their name, which is sorted alphabetically, you do not start from the very beginning, do you? You open the book roughly to the letter S for Sharma, then narrow it down. A B-tree index works in a very similar way. It organizes data in a sorted, tree-like structure, allowing for very efficient searching, sorting, and range queries. When you define a primary key on a column in your database table, a B-tree index is almost always created automatically behind the scenes. This is why searching by a primary key is usually super fast. For example, if you have a user's table and ID is your primary key, the database uses a B-tree index to quickly locate any user by their ID. Here is how you might create such a table in SQL, which then benefits your Java application. Now, B-tree indexes are not just for primary keys. They are also fantastic for what we call secondary indexes. Think about our textbook analogy again. Besides the main index for chapters, you might have an index for specific terms or concepts that appear throughout the book. Similarly, in a database, you can create B-tree indexes on other columns that are frequently used in your where clauses for searching. For example, if your Java application often searches for users by their email address, even though email is not the primary key, creating a secondary index on the email column will dramatically speed up those searches. The database will use this index to quickly find the row containing that email, rather than scanning the entire table. This is incredibly powerful for improving the performance of your application's read operations. Let us see how we would create such a secondary index in SQL. Excellent. Now that we understand B-tree indexes for both primary and secondary keys, let us see how your Java application actually benefits from them. When your Java code uses JDBC to execute SQL queries, the database engine intelligently decides whether to use an available index or not. You do not need to write any special Java code to use the index. You just write your standard SQL queries, and if an index exists on the columns in your where clause, the database will likely use it automatically to speed up the data retrieval. For example, if you query your user's table by ID or email, The database will leverage the B-tree indexes we just discussed. This means faster response times for your users and a more efficient application overall. Here is a simple Java JDBC example demonstrating how you would query an indexed table. While indexes are amazing for performance, it is important to use them wisely. There are some common mistakes beginners make. One big mistake is over-indexing, creating indexes on too many columns, especially those that are rarely queried or have very few unique values. Every index takes up disk space and, more importantly, slows down data modification operations like insert, update, and delete because the index itself also needs to be updated. Another mistake is not checking if your indexes are actually being used. Databases provide tools, like the explain command in SQL, to show you the query plan, how the database intends to execute your query. Always use explain to verify that your indexes are being utilized effectively. Best practices include indexing columns frequently used in where clauses, join conditions, and order by clauses, and regularly reviewing your query performance. And there you have it, everyone. We have covered the essentials of database indexing strategies in just 5 minutes. Let us quickly recap the key takeaways. Database indexes are like a book's index, dramatically speeding up data retrieval. The B-tree index is the most common and versatile type, used for both primary keys and secondary keys. Primary keys automatically get an index, making lookups by ID super fast. Secondary indexes on other frequently queried columns, like email addresses, also boost performance. Remember, your Java applications benefit automatically when you query indexed columns. The database engine handles the magic. Finally, index wisely, do not over-index, and always use tools like explain to ensure your indexes are actually working for you. Keep practicing these concepts, and your Java applications will be faster and more robust. If you found this tutorial helpful, please give it a big thumbs up, share it with your friends, and do not forget to subscribe to our channel for more exciting Java tutorials. Happy coding, and see you in the next video.